Okay, we're live. Hello, everyone. This is Nikolai Smachvalov, Postgres TV with Postgres Open Talks series. We bring great speakers with great talks from conferences that usually were not recorded. And we just record them and we do a live session. So I thank you everyone who joined online because you have opportunity to ask questions. But most people will watch it recorded, no worries. So we also monitor comments section so you can follow up. And today's guest is Sebastian Webber with a very bad topic, right? Corruption.
Yeah, the worst one. Everybody's so scared.
Yeah.
And by the way, that's the idea, to make data corruption less, I'm not sure, less problem, less worrying. So they talk about this and make the problem tangible so we can know what to do.
Right, it's like kind of forms. When you start thinking what kinds of corruption you might have, you are becoming very surprised that there are many types of corruption, and you start worrying more and more and more. So our goal is to reduce this level of stress, right, and to know what's really happening with your databases. And you are going to do some entry level. Talk, right?
Yeah, the idea is to talk about what's happening, to bring some examples about this happening, what to do. But my idea is to be very high level, to explain everybody what's going on, how it works. And if I have time, I want to speak more about the details and how the bad things happen. But there's actually at the end, I'm representing the talk that I did on PGConf PR Brazil, and the idea that I have 5 problems and I have solution for 4. The latest one is a really big problem. So my idea is to present a new talk like here and say, this is how we solve this, because this requires more time and study.
Right. So like a couple of months ago in the summer, we had Andrei Borodin with talking about corruption, but it was quite deep, very highly technical talk, not saying where to start, right? So like today we're trying to fix this gap for those who just starting with this topic. Okay, thank you. Like, let's just start if you want to share something or...
Okay, I have a presentation that I translated, and I'm really sorry if there's some weird words here. So you are here to save me, Nikolai.
It's okay. Well, I don't know Portuguese, but I will try.
No. These are in English, but maybe some words are twisted. But
I will try. No problem. And a quick reminder: if those who watch us online, you can ask questions. I'm monitoring chat. So
and by the way, I would like to ask you, if you are seeing this video today or live or another day, put in the comments your weird case about data corruption so we can learn about it. So this is the perfect place for that, right? I'm not promising that we reply all questions, but it would be super nice to say, hey, I got this weird error. What should I do? Or have these errors. This is documented in the list, a link to the list. It would be super nice to read. So
yeah, like collection of cases. It would be great to accumulate somewhere. But there is page in the wiki, PostgreSQL, covering some cases, not all, but yeah.
Yes. I think I have a slide for that, but in any case, put your questions there or use the comment sessions to scare us, because data corruption is really, really weird. So I will run the slides. Nikolai, feel free to interrupt me when you think is necessary or if you have something to add.
Yeah.
Okay. So I am this GIF guy. Alvaro is really scared about my GIF proficiency, so I'm always using the talks to use GIFs. So if I can use just GIFs, it'll be my best talk ever. So hi, I'm Sebastian. I really like to cook, so this is why I'm a big guy, because I like to cook a lot and eat most of the time. The pandemic showed me that a good thing to do is stay with my family. So without my family, I'll probably end up I'm not sure if I will end up the pandemic. So it was really hard for me to stay locked in my home. Without seeing my friends, just talking to people over the internet, no presential events. So it was hard, I think, to everyone, but for me, it was really hard. And right now, I'm currently working at Postgres as a database engineer, and I work in the Stackers.io, a super fancy and super nice operator to install Postgres is really easy. So if you guys want an operator that works like RDS, this is your guy. And I want to remember everyone that's saying this, because I always put this on my presentation, to have a simple button in the screen, to have something that's really dumb, someone needs to work really hard. So to have an automation, someone needs to study, to test, to validate. So it's a big amount of effort to have something really simple. So the stuff is simple, but don't think that this is because I'm dumb or because stuff are dumb, because the whole point is that to be lazy, you need to work really hard, okay? And I have we do a simple exercise? I'm not sure if everybody can see my camera in the presentation, but I'm sharing my screen, and I'm hoping that if I increase my font here, everybody can see that I have a piece of paper in my hand. Nikolai, can you tell me a number between 1 and 100, whatever number you want, just a number?
31.
31. Okay, you say 31, right? 3 and 1, right?
Right.
So I'm writing 31. And this, ladies and gentlemen, is a corruption case. So this is the basic thing that I can show you about what is data corruption. So I receive a message, I confirm a message, and when I'm writing down the information, I just say something wrong. So, and this is basically what happened on computers. When you lose data, it's not because the systems want to lose data, but something between the whole process about reading, confirming, storing, or just processing data, something goes bad, and that information is no longer reliable. So there's a super Wikipedia definition for that. There's a lot of really good information, but I try to bring the important part, right? And I remember doing that on PGConf, and everybody was looking to me, and I push her. Before I start, I take a piece of paper, ask my friend, she was in the front row, says, tell me a number. And she was super scared, what's going on? And then I asked the number, I confirmed twice, then I showed the wrong number to everyone. So everybody was, wow. And it was super simple, actually. So what's my plan for today? I want to tell how Postgres stores data. I want to tell what can go wrong. When is the moment to get despair, to get really worried about what's going on? Should I change my job and go to the beach? And okay, we assume that everything is wrong. What should I do? So that's the idea. And again, more gifts to make everybody happy. So that's my plan. And how the database saves data. Oh, there's a problem here. I'm sorry. So from a logical point of view, I have a Postgres instance running, and I have databases and other objects. So can be a user, can be a table space, can be whatever. The whole point is to have this simple differentiation. And I have multiple databases inside my Postgres instance. And inside each database, we'll have schemas. This is what now the image makes sense, because it was lost alone in the dark. And between this, inside these schemas, we'll have some objects like tables, indexes, views, and maybe functions. The whole idea is to give examples, not really define a real world, a real life system, right? So, and of course, some tables can create specific type of objects like those that are stored in another schema. But just to give an example, I want here. So if I have for instance, a text field, on the table, I may have a toast for that field. So this is why it's how Postgres handle huge amounts of the text data, create a field in another table, create another table to handle this data. And again, I have this super logical vision about Postgres, and I started to wonder where the data is stored. So everybody knows or should know that there's a data directory. This is the standard on the Postgres image that I was using in the beginning. So it's on Debian-based system, so it's varlib Postgres data, but that place can be anywhere. If you want to know for sure, show data directory, show you the place. It's common that the config files are also in this directory, but there's not a rule. Some Debian-based system like Ubuntu, Debian can change the place and use the proper flags when start the database to change these configuration files, but the data should be in this directory. And when you start to see the objects that I told you before, the databases, we understand that we have these weird numbers, these IDs, to identify the database. But when we check on the directory, we have the same numbers. So there's a relation between the files on the file system and the files that and the tables that contains this logic information. And of course, this is not the only way to store data. We can have table spaces, and table spaces can point to another place in the disk. But the whole idea is that there's a relation between where is the table and where is the table on the disk, right? So another important directory that we have on Postgres is the PGWall, that is the folder that stores these transactional changes that we do over time. So I create a table, I insert a row in a table, I delete something, I update something. This information is stored, it's always stored in a place called PGWall. And that is really important. And I hope to show you an example about how to fix when you lose the PGWall. There's also a really important directory called pgglobal, because not everything is inside the database. To give an example, I have these tables that contains the databases. So this table is stored inside the pgglobal. So if I lose pgglobal, I'll have a problem because I will not have the ability to see the databases on my database. So that is really important. And also inside the global folder, there's the pgcontrol. That is the file that contains data about the transaction committed on the database. So if I lose that file, I probably will not be able to see the data that is committed. I will lose the control about the data that I'm seeing or not. And going back to the database that I was showing before, to know where is the tables, where are the index, there's a really useful function called pgrelation file path that can show that path for me. So I can go back, query the database, and get information. If I need to do something regarding to the files in the file system, I can use this tool to identify where is the file. Most of the time, there's a relation between the ID of the object and the file in the file system. But for instance, if I run an operation that rewrites the file on a index in the index, or a vacuum full that recreates the data file, the number may not be the same. So it's not a guaranteed scenario that the number, the ID, and the table should be the same. The ID of the table and the number of the file be the same. So the function will get that information for us. Maybe there's a table that contains that information. I'm not sure. I didn't dig on this, but
also,
okay.
each file is maximum 1 GB, and it's like shrinked to multiple files. I guess
that was like precisely what I tell, but
okay.
Comment. No, but no worries. And this is important. These files, they are a collection. I like to see them on my mind. This is not how it works, but a collection of blocks. So there's this minimal unit inside Postgres, which is a database block that is composed with a chunk of 8K of data. And these files will accumulate these blocks until reach to 1 GB. And when it comes to 1 GB, we start to create new files and appending the same file name .1, .2, .3, whatever, to ensure that these files are small. And honestly, I don't know if this is a limitation in the past that right now is not really important, or a design thing. To be honest, I don't know. But I know that is the actual behavior, you know? So the file reaches 1 GB, create a new one, and continue the next one. And there's other files that also are displayed in the table, like the free space map definition that Vacuum uses to understand what are these blocks that are free inside the files, so we can reuse those files when necessary. And there's also information about the free space. This is the free space map, but that's the idea. Regarding just commenting about those files that I commented before, so the indexes, they are here too. And let me see what else can show. If you want to know where is a function, you can check that information inside the pgproc. So there's a table for that stores the content of the function. And of course, I'm talking about stuff that can be created. For instance, a function that is SQL, RPL PGSQL. If this is something that's compiled, of course, it'll be inside the library that contains the function, not inside the table. But the idea about if the functions exist on the database, it should be there. Maybe the content of the function will not be there, but the link saying that this is a function that received these arguments, it'll be there, okay? And thanks to Fabrizio that told me the right table, definition of the views is also stored in another table called pg rewrite. So I really try to find out what this view, these functions pg get view def does, and I fail. I fail really badly. So I didn't. I checked the code twice. I didn't understand what it was doing and trying to figure it out. Then I asked Fabrizio. Fabrizio, come on, it's on this table. So that's the truth. What else? The nice truth is that the database uses tables to store objects metadata. So if you have table to store data, the database uses the same principle to store data. And because of that, it'll be easy to solve some problems, because we're trying to fix a table that is broken, an index that is broken, something like that. So that's the next question. What can go wrong, right? This is so nice and so beautiful, but a lot of things can go wrong. So the easiest one is the hardware can fail. So I have a problem in the server, or specifically talking about the disk, the RAM, or the network. Everything can fail. And I remember to see the other talk about the data corruption. He was explaining how the cosmic rays can influence in the RAM processing, and doing that can invert a byte or two, can corrupt data. So because of that, they add this. We need to flip one bit to when saving the data to have a problem. So it's not about I have 100 gigabytes of database. I just need just one single bit with problems to have a problem in the database. And other things that happens in the database can have a problem as well. When I'm running a DML, what happened is that I save the pages that change in the wall directory, in the PG wall, and update the shared buffers with that dirty pages. So if you think about it, I have a drawing to explain how this works, but just to have an idea. I store data on the same time as I update shared buffers and write data on the PG wall saying, this is the changes. Because if I lose the database on that moment and lose the shared buffers, database will start again. We'll read the PG wall, you start to reapply those changes, refilling the shared buffers, and some point in time, someone will get these shared buffers and sync to the disk. So, but if you think about it, when I'm writing data in the PG wall, what Postgres is doing is say, file system, I need to store this data in the disk. And when I do that, there's a software that controls the file system that will talk to the disk controller that will save the data. So there's a lot of things that can go wrong in the process that can make the data corrupted. And of course, the Linux systems are really common that to store data, have these dirty pages in the memory, and time to time the data is synced in the files in the disk, because there's if I all the time throw all the data that's changing in the disk, maybe I will have a throttle, some kind of limitation to have this data. This is why the cache system makes the system works faster. And this is a reminder, there's a super useful thing that we have today that is fsync, that ensure that the data is written in the disk. When I say that, I don't mind to wait. I want you to save this until you say to me that is saved, I will wait. So this is what fsync does. And trying to give this idea on more simple terms, like the user do lots of writings, the databases will update shared buffers and writes the wall for that information, and the user will say commit. Database will say to the kernel, say, hey, I want to sync this data. The kernel will press the file system to say, hey, I want this be saved. The file system will save, and then I come back to the user and say it's saved. So this is some extra guarantee to ensure that this how these work. And there's a super nice blog post. I hope you guys can see in the end, in the bottom of the screen, talking about that thing to explain how this function works. There's other ways to save data in the Linux operating system, like direct.io, but this is not something that Postgres implements today. Maybe in the future, it'll be something that we use. It'll be super nice or super efficient, but we are dealing what we have, right? So this is how it works. About this, there's an entry in the Postgres wiki called fsync errors that everybody should read. So we had a problem in the Linux kernel that does the following behavior. I try to fsync something, and somehow there's an error. The kernel say, I don't know, I cannot save this data now, I have a problem with this, whatever. And when you try again, the kernels on that error happen, the kernel clean up the buffers and throw a message and say, okay, I read the data. So the data was, because of possibly related to a hardware failure, is saying that the data was synced, but it was not. And because of that, there's a lot of problems that you got on Postgres. There's a parameter that I will show in the next slides that show how you can avoid those kind of errors. And this is really common. It was fixed in the newest kernels. For instance, this was fixed in kernel 4.13. And the most operating system that they use, I'm talking about customers, friends, and labs that I saw over the internet and over my experience, running on Red Hat 7. And on this specific Red Hat 7 or CentOS, Rocky, whatever, but the whole idea is that it uses an old kernel. I'm not sure if this kernel has a back patch to ensure that the everything should behave as it should behave, but this is an important thing to take care. If you guys are using an old operating system that uses an old kernel version, this can be a problem for you guys. And of course, there's the links. Don't trust me. Check the links later and actually comment in the YouTube session, the comments, add the comments about this, because it would be super nice to hear about this if you have this problem, or if you guys found an alternate solution without changing the operating system. But this is something that's not really easy to do, right?
Yeah, I've put both links to the chat for convenience. So.
Oh, thank you. And there's another thing that can go wrong. Someone that's really well-intentioned, someone that knows what he's doing can make a mistake. That is a really common thing to do. I have a coworker in the past that we are migrating Postgres versions. And doing that, we create a procedure. I'm not sure what Postgres version was. I think it's 8.3. No, I think it's 8.3 or 8.4. It's a really old version. This was a long time ago. And we write down this procedure about, to migrate the version for the customer, we need to run a PG backup with a custom file. So if the database is not that big, you just restore that custom file in a new DB instance, review the tuning, apply the tuning, start the database, and move on. So vacuum and the tables and move on. So simple as that. And I remember that most of the customer has enough free space in the file system to have two clustered instances running. So that's okay to create a new folder, to create a new, you need to run it in the backend, to copy the data, to restore, everything works fine. But I remember that to have a corner case that a customer didn't have free space to do that. And he asked me for help. And I remember that I was working pairing with a coworker to work on something else. Yeah, I just moved my head to the side to see what he's doing. And he asked me how to fix that. Then I explained to him, hey, to fix that, you have the backup, right? So the backup is there. So what do? We remove the PG data directory, create a new one, and just restart the data. Because I actually was counting out that the customer has a backup routine and stuff. So I was not really worried about losing the data. This is a risky idea. At that time, it was maybe I should think more on this. But what did wrong on that case? I tell him, run rm-rf, the path to PG data, and told him, if you want to avoid to recreate the directory, to fix the permissions, to ensure that post is the right owner, just put /* in the command. So we will remove the contents, but not the folders. And what he typed at the end was rm-rf, the path to the PG data, /* So we remove the PG data and the backup. So doing that, we have a really bad night. We restarted the backup that we have before. It went okay, but teach me a lot about how to review things and how to pay attention at that important moment. What should I do right now? My feeling about this is, should stop whatever I'm doing. I should pay attention. I should review, find another place, ensure that backups are there. To have maybe call the customer and say, hey, maybe you have another server that you can spin up to restore this, make this machine intact. So if you have a problem, you can hold back. But at that moment, I was really limited, or not limited is not the word, but I did my best to be super honest. And this is a really weird case about how to screw up the database without, if between codes know what I'm doing, right? So even if I know what I'm doing, I maybe enable data sync and retry on a kernel that old and can have these fsync problems without knowing. And this parameter is really important because if Postgres tries to run on fsync and fsync fails, we'll panic and we'll stop. And now have a full log entry saying, I cannot write data into this, something is wrong, I will shut down. So you need to fix whatever is going on. But the whole point is that the database don't know what to do, and you do nothing until you fix the disk. Another thing that can go wrong is put the fsync to off. Maybe you want to do this for a restore reason or to test something. This is okay, but for production, it's really risky to run on fsync off. Even if you transfer your storage, your database server, and whatever, it's really risky. There's a lot of fail safes to avoid to lose data, and fsync is one of them. Another thing that can happen is not really frequent, but it happens, is the database bug. So this is the latest one, is really known, but maybe there's others. I use this one because it has a nice image that explains the error, the problem, and how to fix it. The fix is not really hard, but the whole point is that can corrupt data just using the database, you know. Now is the moment that we need to know if I really despair or do something else. Maybe start to sell coconuts in the beach, you know. Forget about IT. And on this moment, I always tell everyone, I would like to make everybody think about this and say, take a deep breath, take a pause. If you are wake up in the middle of the night with a problem like this because the database is down and everybody's suspecting that we lose data, now is the moment to think and think more than once before doing anything. And if you got this problem, you probably will be awake the entire night and part of the day until you have something working so you can go back to sleep. So now is not the moment to run Stack Overflow commands without thinking about it. Now it's not the time about create our functions to fix everything. Now is the time about think, test, and work safe, right? So patient maybe is the key for that, but it's not really easy to everyone to be super patient and super nerves of steel to do this to solve this kind of problem in the middle of the night. And for that helps documentation, right? If I have some problems on my infrastructure and start really well documenting things in the middle of the night, I can copy and paste commands that were tested and validated and safe. So when something like this happens, when you have some problems that we are thinking about data corruption, it's really important to know what is the error, what's going on. If you suspect this, the second thing that I can do is, okay, there's an error. How can I reproduce this? I need to understand which parts of the system are affected. I need to understand how the system that you use in the database is affected. So maybe you can isolate that part until you fix it. Maybe you need to shut down everything to fix something. This is really important to understand what's going on. And to do that, I have a few examples that may help. That every time that I run query X happens an error. If I run a command querying a table that contains huge amounts of data, the database fails to deliver that query, but just happens on that query. That can be a sign that just that table or that tables are involved in the problem. I run another query and the query is waiting. I have this problem. It was really hard to understand what's going on. And I'll double check twice or thrice what was going on, and it was not a log related. It's something else. The database is hanging, and when running a query, I don't know what to do. Error in the logs. Usually, everything that happens in the client will have an entry in the log. So if the user does not tell you, the log will tell you something is wrong. So to give you a few examples, when running a query that uses an index, there's an expected page in the file. There's an error here. There's a limit. Let me edit this so you guys can see that the command ends here, that the message ends here. So the database tells you what to do. That's really nice. And the index is really easy, right? I have the data, I can recreate the index and move on. So from the Postgres data files, when Postgres cannot read a part of a block, we'll complain about it. And most of the times, those errors are silenced to the point that only when that specific amount of data is queried, maybe once a year, once every 6 months, or once every month, I query that data, and maybe this error is there forever. But since the data just query with low frequency, you do not have this habit to check the logs with frequency. This is something that we know about it. So this is really important. And of course, any panic index should be something that you need to check out in detail. If I have a panic, this is a log operation that says database will turn down. Something happened that's so bad that I need to shut down. And this is happening in your server, and this is this is actually true for every system. If this is happening to you, doesn't matter how critical it is, you need to investigate as fast as possible. Something really bad is happening. And the easy way to escape from this lot of problems is restore the backup. If you have a problem that is related to data, and just restore the backup. This is the easiest way to get free and do something else. Of course, we are here because most of the time the backup's not there, or it's not working, or it's not reliable. So this is another problem to attend, right? And of course, if the backup works, my suggestion is that to have another server and restore another server. Let this place as a safe place to check later. So if I have the opportunity to create a new server, in the cloud is really easy, right? Spin up a new server, start a database, wait for the restore, check things, run the queries to ensure that everything's okay, start the system, and move on. But and I'm using on bare metal, that can be hard. And if I not be able to use another hardware, maybe another disk. If this is running on a disk over the internet, maybe have another loon to restore the data, or maybe use another disk to restore the data. Ideally, this scenario of problem, I should keep quiet and check them later. If there's a disk with failure, will fail again. Not magic, reboot the server will not fix the error. The error will be there forever. So we need to do something to fix it. And okay, there's no backup that can save me. I need to do something. And now it's important that I ask for help. If I'm working on this, I'll ask for more people to help me. First, to make me think as a team, to have more ideas to solve the problem, do something that will make the system up as fast as possible, and do movement that's not that risky. And when I ask him for help, other people can help me to do things that are hard when I'm working in hard problem, like documentation. For instance, we talk about a problem, and we are in the call, you are working the server, and asking you what's going on, what to do, and then documenting to the rest of the company or the team, hey, I'm here with Nikolai, working the problem. We identified that this error, and because of this error, we're taking this action. And of course, that can be in the issue, that can be on a mail, that can be in Slack, it doesn't matter. The whole point is that someone else is helping you to get this information and to centralize the communication on him or she, so you can be free to work on. And if more people is working, let's make sure that just one person is working in the server at the time. So to avoid problems like I have an idea and I'm running a command to fix something, and I can, bring database down and corrupt more data. So this is not rules like you need to follow to save your life, but something that will help on big problems with a lot of people, right? And okay, now is the problem that probably everybody was waiting. I have a problem, what I should do. So I have 4 examples. Oh, of course, this is more important than my examples. Whatever you do, we copy the data. And always works in the copy. This is super important. There's a presentation that's really old right now. It's the worst day of your life. It talks about Postgres, data recovery, and lots of issues that they have. I'm not sure who is the speaker, but the presentation is super good. And I remember this message was written in 4 or 5 slides, like before, new slide, anything, copy your data. So it was super nice. And this is a really important message. Whatever you do, I found someone that fixed this on Stack Overflow. He's the super guru of Stack Overflow, has 2,000 stars, and is the best person in the universe. He knows everything about Postgres. He's telling me to do this. Okay, let's do a copy and try the weird commands on a safe space, on a place that will not bring more problems to fix, right? So that's my idea. I have 5 problems that I'm bringing here. And if you want to try this, please do not test this on the production server. Most of the tests, I have a repository that I will send to Nikolai later that I create a virtual machine, start Postgres, run a few commands, and break the database. So the command that I use is on the beginning of the slide. And then I show the problem, what I did to fix it. So most of the times, the problems are not that hard to do. To give you the example, if I somehow corrupted data inside a data file when I try to read it, so I'm trying to read a query table called customer, and there's an invalid block in the table. So doing that, I need to identify which is the index that is complaining, because there's a file here that's complaining. And that's the case that the ID is different from the file node, right? So what I need to do is to recreate the index. So there was an index with problem, identify the index, and now the query is running again. So that's really easy to do, right? A simple solution for a simple problem. But the whole idea is that most of the problems that you have are fixing a data from a table or fixing an index that is wrong, because everything is a table or an index, right? So at the end, the low level, everything is a table or index. So most of the problems that you do is that. And this is the easiest hack that you can do, and say that I survive a data recovery operation. And doing that, there's no data loss, right? So I'm recreating something that was thought to be recreated. And other thing that can start to become harder is when I have a system index that is broken. For instance, if I have an invalid index and I somehow corrupted some index from the database system, and I shut down the database, do not start again. We get a fatal error, say, I cannot read the index, and good luck. And this is it. This is me shutting down. And there's something that can help us in that case. That is the single mode in the Postgres binary. This is made for the developers to create new features, to validate things, to do maintenance tasks, but you can use that to fix that problem. Because when I try to run the database, to run in single mode, you to fail with the same reason, right? Some fatal, blah, blah, blah. But when I use an options to say ignore, I'm not sure if it's the dash P one, I'll check I'll show the hidden in the next slide. I can disable the system index, so I can run the query to fix the index that is broken, then I can start the database again. So there's by the way, this number is 2662. I checked the code and is a fixed dump. This is why I knew that is a system index. I'll check the code. So there's the reference where the number comes from. And the options to disable system trigger is this one, -P. So this is why I know. And this is the second fix. Go ahead.
Yeah. I noticed you do reindex system, so like all indexes, but if database is huge, we can try to narrow down the scope and reindex only those indexes that are really needed, but we should find them by OID, right? So it's also an option, right? There is no need to reindex all. Right.
Yeah, I propose to use a reindex system inside the specific index, because I know that the catalog is something small, kilobytes of data, maybe megabytes on a huge database with lots of tables and objects. But you're absolutely right. Since database is down and I need to make this work as fast as possible, let's use the index that is wrong, let's fix that and start up and move on.
Yeah, I wonder if conversion from OID to rec class would work. Would we be able to get the name from OID if we disable indexes? Probably no, right? Or maybe
I'm not sure. But maybe it work, because it will run a query without the index. It'll be slower, but it work.
But it's a good idea, right? Well,
yeah, of course, it's a good idea. So that's my hack here. The single option that I commented here. This is just for reference. If you got to the point to check to start Postgres, check the manual. That's the better than my slide that is cut to have the important options on the screen. Check the manual, read the documentation page more than once if you're not sure. And please do not test on a living data. Do not start to test in your database because you saw my presentation. I think that's really fun. And from now on, that's the moment that I start losing data on my examples. So this is a hard thing to do, but sometimes this is the only solution that you have. If I don't have a backup that works, and the only thing that I have is the data that I have in the file system, this is the best that I can do, right? There's no way to recreate the data that I don't know where it is.
Unless this data is derivative data, for example, materialized view, or one case I had actually, Alvaro knows.
This is actually a good example. Yeah. If you have a
PG statistic also is also not a problem to recreate. It's also data, but it's easy to analyze. That's it. And PG statistics, if you have corruption in PG statistics.
That's actually a good idea. There's some corner cases that you can have the data back, and some tables that we don't need that information. But I will show some examples that you will try to recreate the files for PG control, for example, and some other tables will lose data because you lose the control about it if it was committed or not. Let me show you. So this is about PGWall. There may be something works really bad and I lose the PGWall folder. Or I run a command to clean up the files because I think nobody is using those files because the file is huge, because I had a problem, or maybe this is another disk and I lost the disk. So there's a lot of possibilities that I can lose that data. And for that case, there's a tool called PG reset wall that can reset the write ahead log information. And doing that, I may lose data. Because I may lose data, because if everything is committed and the database was shut down properly, it's possible that all the data is relevant. But most of the time, database goes down is on a power failure or something that there's a bug in the software, a kernel panic, whatever. So some really weird situations that database do not stop properly. And because of that, the data that is stored on PGWall is probably stuff that was committed but not syncing the disk. So losing that information can lead us to the problem that lose data. I may have yes, I have some drawings to explain this better. So the user writes data in Postgres, and when it does that, even if the transaction is open, the information is not committed, the data will be changed and updated in the shared buffers and written data in the wall. So time to time, there's a background worker, a checkpointer. Even if the checkpointer is not running or there's not free space in the shared buffer, maybe the backend itself can write data if necessary. It's not a common thing to do, but it's possible to write that data in the file system. So that happens all the time. Of course, non-committed data will not persist in the file system, but they got the idea. And when I lose the database, I'll automatically lose the shared buffers. And the only source of truth of that information that was not persistent is the PGWall. This is why it's super important to do the best to not lose that folder. But if you do that, go back to PG reset wall and that can fix for you. Okay. But I think this is a really easy hack to fix. It's not a good thing to do if you lose the data, but there's no option, right? Maybe you can try to recover the disk or do something to get those files back. But I'm not sure if that you paid the time and effort to make the database going back. This is a hard thing to think. Okay, so there's a folder called PG transact, and that folder contains a lot of files that contains information about transactions.
I have an idea. If sometimes we might lose some files in PGWall on the primary node, but maybe they are present on standby nodes or in backups if we have continuously like PG backrest or VALG. So before resetting, probably we can also look at backups and maybe we can restore some walls and so on. Right?
Yeah, of course. The restore is always the best option.
Right.
It'll be easier because there's a file missing. And when you restore the data, you can make database heal itself.
Just manually take it back and try to start up, right?
Yeah. Of course, that's a very good idea. And maybe you should update this before running the reset. Try to restore the database first, the files from the backup first. So another thing that can go wrong is the pg transact folder lose the files. That can be an error, a human error that delete the wrong folder, or a file in the file system. Lots of things can go wrong that can corrupt that data. And when you lose those files, I have a problem that I don't know which transaction is the latest transaction that I have in the database. And why this is important? Because the way that Postgres stores data, the rows contains information about the transaction that was committed. And when we are running a data query, and to get the data, these transactions are adding the query to ensure that you are just seeing data what was committed or is in your transaction. This is why this is how database do to ensure that you're not seeing data that's not committed in your transaction, that it just seeing data that was committed. And when you lose that information, the database doesn't know what to do when you query something. To give you an example, I lose the file that I remove here. I lose the file. I restart database and start over. Database started and complains about the file, but started. And I try to create the file using DD. The file, it works, and database started. So I try to run a query, and the PG attribute is missing some attributes from a view. And this is a very common thing because the data was not created at the same time. So it's expected that when I lose the information about the transaction, I may have another problems. Of course, I can try to restore the files. As you said before, it was surgical. If you have the file, add the file back, will solve the problem. But if you don't have the file, you can create an empty one to, and between quotes, fix this. But this will have more problems, and now you need to dig what to do. For the PG attribute, maybe try to get this on the backup or on the standby server to get those data and maybe replace the tables. It'll be a solution for that, if that's the case. But if you have a replica, you probably you do a failover and try to fix this one, right? And about the CLog information, there's a very interesting page. If you don't check this website yet, I really recommend. It's interdb.jp. The author is always updating this. There's a new version. There's probably information about PG 15 here, and is explaining things that is hard to understand, like how the CLog works, and how the data is added here, information about each transaction, and when the Postgres knows when to remove that entry because the transaction is too old. So it's really interesting, and he does a lot of drowns about how this works, and I found it really important to share with you guys. This error here is something that's not really hard to fix, but it's a pain in the ass most of the time. Sorry for the bad word. What happened here? I ran a DD on database file that is a toast table that will contain some value of the table. So I create a function to identify which row was failing. So my solution, and I added the vacuum full. The vacuum full is not really necessary, but just added the vacuum full because I work with a few customers in the past, and all the time they don't know what to do. They run a vacuum full. This is my internal joke. So if I'm sorry that makes no sense for you, but that's me trying to be fun. And even a vacuum full can do the trick. Will not read the data. Will do nothing about it. But if I know the row that has a problem and update the values and remove the value from the table, I can go back and use the table if necessary. So this is a way to fix those two tables. Of course, if there is a way to get the data back, to give an example, if the data is loaded from a file or for someplace in the internet or somewhere else, I can use the update to get the data back and fix this. Of course.
Can you move back? Sorry for interrupting. It was interesting on the previous slide. This
one? Is this one?
This is CTID, right? Page number.
Yes. Yes.
So technically, we could try to find the row using just CTID, right? But it would require full table scan because we don't have index on it. But not necessarily we can just try to delete this tuple, right? Tuple.
Yeah, on my case, I since the table has more columns, I just preserve the data that I have and remove that I don't have. So for instance, I set update on the bio column set to new. So I will
Just
remove
update.
that data. Yeah.
So,
but the function is here. It's not that super smart function. It's really dumb actually. I do a select on the table, run by row, and try to get that, do whatever function that I need to do to read that data. So since I'm reading the data, I will trigger the error. And there's some exceptions for that, like internal errors, data corrupted, index corrupted. And I put a message, failed to work with the toast, blah, 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 and found an error and continue.
The key here is that we don't stop and we want to find all issues.
Of course, that can be really slow on huge tables, insanely slow. But for that, maybe you need to change the approach. To use chunks of data, try to read, 100 rows at once, or 1,000 rows at once, or maybe define these ranges and start on parallel on terminal 1, 10% of the table, on terminal 2, another 10%, and go on, right? On huge tables, we need to be experimental.
Or try to do binary search, read the half table and half table, and then go down in binary tree. Like it's
yeah. So when we're despaired, there's a lot of solutions to test.
Yeah, there is room for creativity here, right?
Yes, it is. And now is the part that everybody goes crazy. And what I did here, I did not answer this because this is hard to answer. And honestly, I would like to have time to run a presentation on this. This is the scenario when I lose a system table. I'm not sure if PG type is broken here. I think it's PG type. Not sure. But yes, PG type. There's the comment. The first row tells that's PG type. But the whole point is that I'm losing the data. Of course, this is the comma that I use to make the data dirty and the table not able to read. But the whole point is that can happen without me running DDs on the server. And when I cannot run a table, I maybe try to do something else, like try to restore. I have an ideas, but I didn't have the time to put this on slides. What should I do now if I have this problem and I cannot read the system table and the contents of a system table? I can run, if I have the backup from this or PG dump of the structure, I can restore in another database, can create the file, just replace the PG type that's broken for the new one and fix the IDs. Maybe the objects can change the IDs. I can update the table with the new IDs and move on. Like I have a problem that gives us a partial solution. And when the partial solution, the new stage that I have a new problem, then I fix it and I move on until no errors to fix that. But this is something that I would like to, maybe next year's on PGConf I will present, because this is really something maybe that I can find a better way to explain this, because it's not simple, right? And I'm not sure if I have, this is, I prepared 5 examples to give you ideas, and there's always more, right? If I still, you can have to recover the file system, that's another journey. This is a lot of heavy drugs, and depending on the file system can be super specific. For instance, I have a problem on X3 file system and you try to recover. Now I have these awesome tools in the internet that you download the ISO, install on the pen drive and put on the server, and can check the files and can give you a network volume that contains the data restored, can copy to another system, but at that time it's not that easy. Even if that's not working, maybe you need to call a company, a third-party company, and say, hey, I need your help and your expertise to get data back. And again, this is all the solutions that I propose, the problem I explain, they are all needed. They are dependent of the PG data available. If I don't have that, I need to have the PG data to work on. So that can be possible, but that's not easy to do, right? So we need to ask for help. And I had a problem with a customer a lot of years ago. And this is something that is not under ADA anymore, but that I think is nice to comment. I work on a system, on a company that they have this super server. This is, I don't know, 12 years ago. And they have these servers that they bought to run presentations. The machine that was designed to be 0% secure, 200% fast. So machines with 2 processors, at that time, I don't know if 100 gigabytes of memory, that was a lot. Lot of disks running write 0, because the idea is to have a super fast system, not really safe, but a fast system. And they go to the customer, put the server in the wall, put on the network, and then they a few presentation they even take the network switch with them, so you can connect the server with the laptop and show the system running really hard queries, and I don't know, the entire year of the demo database to see in a few seconds. They say, wow, this system is super fast. And there's one time that they left the system, the server in the customer as it was, with async off, write 0, with all the tunnings to make stuff unsafe but fast there. And the system worked for years. It's insane how fine Postgres can work for years without no supervision, until that stopped to work. And they call us, and the server was offline, no SSH connection. The person that called us didn't know what to do because he's not an IT person. And okay, if the server is not up, I cannot help you, and my team cannot help you. So maybe need to find some technician to go there and go there to the site, to put a monitor on the server, to see if the server is starting up, to check the errors in the file system in the server to see what's going on. And when I have SSH and I have the disk to work on, I can help you. But until there, I'm waiting. And the guy, they find some super magic technician that goes there and so, oh, there's a problem in the hide, and they start removing the disks and changing the order and start without a few disks, and the write goes down and they lose the data. Then and the guy do that all day long. And at the end of the day, I don't know, 10 p.m., 11 p.m., they call me, they find my number, no, I don't know how, and they call me, explain what happened. And I remember that we talk in the morning, and by the end of the day, they call me and say, hey, we are super desperate. We need to help us. We don't know what to do and everything. And this is a company that's a great system for trucks and management system, store management system. So they all the time they have the same expression, say, all my trucks are stopped in the front of the company. They cannot leave until I finish the order, so they can leave. And okay, if you are full stop, I will help you. Let me know what happens. And I remember that he went to my place with the server in the car, and he goes back to the company and start the server, and there's no disk there. And say, fuck, I don't know what to do. So okay, let's go back to the basics. Let's see if you can see the data again. And I try to run an ISO with a dump file system to see if we get no data there. And after 2-3 hours trying, okay, guys, maybe we need to restore the backup. And the guy who is the manager say, which backup? You guys do everything for us.
What is backup?
Yeah, and he asked me, which backup? Do you guys have a backup, right? Yeah. And it was super, that was a weird conversation, because I told them, okay, but this is your data, your responsibility. If you guys don't have no backup, you can ask our help. We'll help us. We'll help you guys. Say, oh, do this, or give me a place in the network to put the data. We'll help you. This is what you do. But you guys need to tell you, we need help. And after a while, I was digging on our server files, and I find out that software engineer had downloaded a database backup from, I don't know, 2 weeks ago, 3 weeks before the incident. And I told him, hey, I have a good news. It's not a perfect news, but it's some news. I found the database 3 weeks ago, from 3 weeks ago. So this is the best I can do for you. And he told me something that you never forgot. Say, I can restore your data from 3 weeks now, but I don't know what to do about these days. I don't have the information to type that for you, to do something to get the data back. And he told me, don't worry, we can put a lot of people to type again. They have the information printed. And I don't know how many people work over a few days at night until late and put the data back. And that was insane, but they are super worried about having the trucks out there. They don't care. So on that
restore
time,
from paper backup,
yes,
right?
that was insane, but it's exactly how it works. And I remember that I learned my lesson. When I start the server again, I fix the hide, put a right hand. I review fsync configuration for the server. I try to power off the server a few times if the database will throw some error or if the server will complain about the disk or something. And I was more and more content about the output when the server leave the office. But that's the idea, right? And this is something that was kind of common to me for a while. People were not worried about the servers, about the data. They just don't care. If you have a lot of people to type again.
Do you advise to print database on paper? Or
so that's actually a good idea. A manual backup.
Like 100 terabytes of data printed. In this area, like I would like to ask you about proactive actions we should take, should do to prevent or at least to know that corruption happened earlier, that it hit users or like more users. What to do?
Yeah, that's the idea. That's the idea.
So
if I fix the problem,
basically in two specific areas. First of all, monitoring. I wonder if things like Datadog, which is like quite popular, will they report about error messages you showed about corruption or no? This is very interesting. Or you should tune it additionally to have such alerts.
I think that would be nice to have a monitoring system that takes care about the logs.
I think every monitoring should report it. Every monitoring. Actually, while you were speaking about, I recall that if you check error codes in Postgres, there is the last section. It's called class XX, internal error, and some kind of corruption will be reported using this XX000 or 001 or 002, three error codes, but not all types of corruption. There are sometimes silent corruption, like caused by glibc version change, right? So it, like at least some hard, like obvious corruption cases should be reported by monitoring, right? And it looks like we need to tune each, or at least check that monitoring will complain and deliver information, right?
One thing that I think you can help everybody is to create routines to test those things with frequency. Like every year.
This is the second part of my question, how to test. But let's finish discussion of monitoring. Does Stagres have it? I know Stagres has monitoring component. So.
Yeah, Stagres has a lot of good care about monitoring. There's a lot of automatic data that is collected and printed in beautiful dashboards. But not sure if there's an alert for that right now.
This is a follow-up.
This is something that we need.
Right, we need to follow up on it. And the second part, exactly how to like monitoring, for example, okay, we ensure that we will get alerts if something will pop up in logs. And of course, a second type of alert from application, if users deal with unexpected error on application like 500, we should also monitor it, but it's probably already covered. But second part, exactly how to test, what to test, like how do you see it? Maybe like, I don't know. First of all, backups. We should test backups, right? Definitely.
Yeah. The backups is to avoid this weird talk. We need to have a working backup. This is the easiest way to avoid this. But a really easy hack to do. It's not a fast one, but it's an easy test. Is use pgdump. Point to dev null to not store this anywhere, and because pgdump needs to read all the data and all the columns for all tables. And most of the time we use index for that. So running pgdump on the server will ensure that I can read the entire data. And if I have a problem, pgdump will explode in your face, throwing the table, the rows that's failed to read, the error that you need. And this is also triggering an error in the log that to show you there's something wrong.
Yeah, that's a great idea. We also use it, and this will help to see data corruption in tables when we have backups at physical level, like pgbackRest or WorldG. But pgdump won't check indexes because it will read only data from tables, and that's it, right? So it won't show you some indexes corrupted. And this in this case,
but for that, there's extension for that, right?
I'm
not
check,
sure
right,
if it's
right.
AM check, yeah.
It
Sure.
doesn't cover everything. Like gist and gin is still under development, as I remember. It's not yet like there are patches. They work, but not still not considered as a production. But
I'm
for
not sure
B3,
yeah, that's not really perfect. But I know that can be a pain in the ass to fix some index when the tables are huge. But the good thing about them is there's an index problem. I can disable the index and recreate it later. Of course, the queries will suffer.
Smaller issue, right? You're right. Actually, it's a good question. Prioritize all types of checks, and definitely check would be like second item, not the first one, because data is the main source of truth. So the tables, I mean, and of course, pgdump should go first. Right. It's interesting. Like I remember we in one place we implemented check but didn't do pgdump. Like database is too big. It will take some time. At least like I don't know, like at least once per week we should do it anyway, right? And check should go second, right? I agree with you. Interesting.
Yeah, of course, it'll be super nice. You can put that on monitoring to run the queries. I remember that the other talk has something like that, really tight connected with the monitoring, that the monitoring run the checks, I don't know, once a few hours to run these queries. But this is something that is
on production.
intensive. Yeah.
Yeah, on production, maybe no.
Yeah, and by the way, all these suggestions, they are IO intensive. When you're running a pgdump in the middle of the day, you'll not bring down the server, will not lock the data. But the whole problem is that the IO pipeline that can process a lot of queries will be limited to run a pgdump that goes to dev node. So of course, this is safety. This is important to have the data. This ensures that the data is there, but ideally run this on overnight in the moment that the system is quiet, do not harm the user. So this is hard to know. We need to understand your workload better than anyone to say this is the moment that we have to run this. Maybe the database is so big that we need to split the tables. Today we'll run this table, tomorrow the next one. And this is the trick. We need to find a way experimenting. One thing that's important when talking about have a problem and find a solution is to store evidence to check later. This is important because if you not understand what went wrong, we're not able to prevent that happen again. For instance, in the middle of the night, you type a super hackish command that fixes all the problems, and you do not take notes about this, not tell everybody, not tell anyone about this. Do know tomorrow morning you probably forgot what we did, and it will happen again, and you say, "Fuck, what I did? Where is the logs?" Right? And because you are awake during the day, you are thinking, you can do that more with more efficiency, right? And you can, for instance, write a manual that can have copy and paste comments for you in the middle of the night, and that's really useful. When you have these data corruption problems, this is always opportunity to review and rethink our database backups. Most of the times we have this problem because we don't have a backup that works, that is validated, that don't rely on that. And if you got to this moment, this is a clear evidence that you need to rethink the backups. Maybe, I don't know, every month plan to create a new server, restore the full database, run a few validations, ensure that is documented, and maybe create that copy and paste command that I told you. Have a wiki page that say how to fully restore the database from the backups, and do that. And run to do the same thing for other things, like how to fully fill over a replica, or from how to create a replica from the backups. Something like that. And that information can help us to avoid a scenario in the middle of the night. And when you do restores, there's a price on that. When you create a server that is really big, that's a lot of memory, lots of CPUs, lot of network bandwidth, a lot of disk, really huge disk to do this, there's a price on that. So when possible, try to have the same environment, not the same server with the same IP, but similar machine types and similar hardware to ensure that you are working on a safe environment that's equal to the production environment. Because doing that, we know that the command will be the same. The tuning that you do will be the same. But if you have different, because the budget limitation, and of course, it's not possible, not trying to burn the money that you have on something that will not be used in production. But the point is, if you have the same environment, it will be easy to do things on the middle of the night, then do this in the middle of the day. Oh, for that environment, I had this tuning. Now in production, I need to use another one. In the middle of the night, I need to compute the tuning and review and test a lot of things. And if you think that to test in the same environment, it'll be super easy to do this on work hours, to have to take notes, to optimize the values, and then apply in production when necessary, it will work perfectly, right? And the last that is important to comment is that a good backup is one that restores. Doesn't matter what the tool says. Doesn't matter what your friend says about the backup. If you're not working, doesn't matter. Doesn't matter, right? Honestly, if you have one backup, you have none. If you have two, maybe you have one. So if you don't trust your backup routine, so that's something you need to work on, right? And there's a reference to HBO TV show that is called, it's about the Chernobyl. And I'm not sure if I'm doing bad things saying that, because I think that is really something that dumb to say. That I remember the guy saying trust but verify. That is related to me. It's related to the backups, right? So the whole point is, okay, there's a backup there is going on, but if you not check it, you're not sure. I'm not sure if this is something else related, but I remember for the TV show. And that's what I have for today.
Yeah, actually, I have an addition to verification of backups. If we do it on physical level, we have usually periodical full backups, like base backups, maybe with some deltas additionally, and also a stream of walls. And sometimes people forget to check that. For example, we have daily full backups and we have 24 hours worth of walls. And when we restore full backup, we only check the beginning of this 24 hours of walls, but we should replay until the last point, till next backup occurred. So we need to not forget to replay all of them to be able to restore to the latest possible point, right? So it's like backup verification. It's a whole big topic, right?
Yes.
But I
maybe we need to talk for that, right?
Yeah. Maybe, well, actually, I see tooling is not perfect in this area for various backup tools. There are some tools that help verify, but not ideal still. Okay, good. Excellent. I feel we touched only the tip of the iceberg, but maybe it's good not to go deeper, because otherwise we don't have a wider view on the topic. Good. I don't have any questions. If you want to discuss some particular topic, we can, but maybe that's it. Just let's leave it as is, because it's good as it is.
Yeah.
And we don't have... we don't have questions in chat this time. Only hello, hi.
They're shy. They're really worried about we bringing down the database and not worry about fix stuff.
Yeah, let's remind our viewers that we want horror stories in comments. I will probably very short one. I have some short one. GCP. Yeah, GCP. If you work with various clouds, AWS, GCP, others, GCP page documentation about disks. They have like section disk performance, and they show how to check performance manually to ensure that throughput, IOPS are good, and latency, of course. And they have snippets for FIO command, very popular tool to have micro benchmarks of the disk subsystem. And I grabbed some, I usually Google it and just grab this snippet and use it. There are various types of it: throughput-oriented, latency-oriented, random, sequential, and of course reads, writes, many kinds of them. And one day I was working with quite old system of it was in some data center, VMware, CentOS, and we have Postgres. We had several disks, and PGData was on. PGData occupied one of the disks fully, so it was mounted like varlib PostgreSQL. I don't remember, and varlib PGSQL maybe in CentOS. But the idea is that I'm grabbing the snippet. It was working system. Fortunately, it was not production, or it was just a standby, and I was quickly fixing it. So the problem was I'm taking the snippet, and snippet says like choose your device. It was SDB or something, Def SDB, for example. I'm choosing it and running, and this is PGData. So I quickly realized after a few seconds that I'm writing to PGData directly, like stop, no, and then I'm thinking, everything is fine, right? It's working. But of course, corruption there. It's not noticeable for some time. But I needed to fix it. I needed to rebuild the server. But it was very. If you take the snippet there, it's easy to shoot your legs off quickly.
Yeah, this is why it's super important to not copy paste stuff from the internet.
Right. So it's similar to your DD from your random.
The idea to have this snippet is to show that it's super dumb to create problems.
Yeah.
Don't need to be an expert.
Yeah. Right. I also want to advertise once again. There is a small project on GitHub from Alexey Lisovsky. It's called Noisha or something. It's to break your Postgres. Some various ways to break your Postgres to cause damage, and some tool for DBAs to make some damage and to learn how to escape from there, or how to notice it and so on. Not for use in production, of course. But maybe sometimes people, like you mentioned, switching off power, you did it with basically production server. Maybe it's also should be a part of testing plan to make failovers and some disaster once per year. We cause disaster ourselves and brief downtime and measure RPO, RTO, and so on. So maybe it's also.
I remember IT director in a company they worked in a project a long time ago that they hire a third-party company to say, have I want outside failover system, and they pay a lot of money, and they made the systems, the database application, storage application, all the magic buzzwords that you need to hear when we're C-level. And someday the guy goes to the IT department, ends the data center, and turns the power down. And I don't care. I pay for this. This should work. And it was working, but it was scared as hell.
Yeah, I know big companies who do it. If they host multiple data centers, they have a plan to turn one of data centers periodically off fully and see that everyone survives and users are okay with it.
It's super hard to do.
It's super hard to do. It's very good aim for to have. Tests like this, right?
And not all the companies has the money to do that. That's the other
point.
Well,
yeah, it's expensive thing. I think there are special engineers who just take care of this to be possible and so on.
These guys are having fun.
Right. But yeah, right. Okay, good. Thank you, Sebastian.
Thank you.
Enjoyed. Yeah.
Thank you, everyone that is listening to us. Please don't run the commands on your server. Put your other stars in the comments. And that's it. Thank you.
And like and share as usual, right?